Hey guys, so let's discuss new round today for Maison, and the question is here. This is the system design round, and here you need to design a Maison Prime video. Okay, so see, when you are a software engineer, okay, again let me describe that here we will see each answer point of view of three roles. Okay, first one is software engineer, senior software engineer, and architect. So we will discuss for each role, okay, so that at high level you will come to know that what is expected, okay, from each role, and then which level of answer you need to give. And this one will help you to level up also. Okay, so let's say in interview, if you are giving the answer, if you are a software engineer and you are giving answer for senior software engineer level, then definitely they can consider you for the next level. Okay, so that's why. So what software engineer will answer for this if someone will give that the question design Amazon Prime video. So the expected answer would be from his side is that before designing the system, I would clarify few requirements. Okay, so what requirements you need to ask him, the interviewer, that should we support both video upload and streaming. Okay, so video upload means, let's say I'm a content creator and I have uploaded video in Amazon Prime, and then millions of users will watch that video, okay, live or streaming. Okay, not live, they will stream the video, they will not save video in their system, they will just get the video from CDN and then they will watch it. Okay, now there are lots of steps involved between that, and we will discuss all those things here in this video. So then second question, he will ask that is this video on demand only or also live streaming, okay, like cricket match and all, and expected scale. So what will be the user, video, concurrent viewer numbers, like how much number the system should support. Okay, now support devices like web, mobile, and smart TV. So it should work on smart TV, it should work on web, it should work on your mobile, right? And then do we need recommendation and watch history? Now for this discussion, I'll assume global video on demand platform supporting millions of users. So this is the scale. Okay, the scale of the user is millions of users, and this one is global video on demand. So from globally anybody can see, okay, can use your application. So now support you're designing a video, suppose you're designing a video platform. Okay, so video upload means a creator upload 500 MB video, and then video streaming means millions of users watch the video without downloading the entire file. This is what I just explained. Why ask this? See, because why you are asking this question? So because architecture changes. Okay, if you need only upload, then need storage, and then upload APIs, and then metadata databases you would be required. And when you need upload plus streaming, okay, so need video transcoding, CDNs, adaptive bitrate streaming, HLS dash, and then caching, and much higher scalability. So we will talk about all these things, like what is transcoding, what are the role of CDNs here, okay, content delivery network, what is adaptive bitrate streaming, okay, and then HLS is I think for Mac and iOS, and dash is for the Android, okay, or Windows. So now caching and much higher scalability. Okay, adaptive bitrate streaming means ABR. Okay, so let's talk about what is ABR here. Means the video player automatically switches between different quality levels like 240 pixel, 480, 720, 1080, 4K, okay, etc., based on the user's network speed and device performances. So when you watch movie, let's say your network bandwidth is not that good, means the speed is not good. Okay, so in that case you will not see buffer nowadays, right? Buffering symbol you don't see, the video quality will degrade, okay, but your video will be continue, so it will switch automatically to different files. So let's say I am a creator, I have uploaded one video, and then in backend what this system will do, it will create a copy of this video in different formats, okay, different pixels. So like for 250, 240 pixel, 480 pixel, okay, then 720, 1080, 4K, and then when user will ask for that video, it will upload, okay, it will download the different formats from the video, and then will show you the one which is relevant to your network speed. Okay, Now high level architecture, if you see here, so see, user is watching let's say video from mobile or TV app, okay, and then so it will go to API gateway. Okay, first I told that I wanted to watch this video, so request will go to API gateway. From there routing, authentication, rate limiting part will be done. Okay, that you are a authorized user, okay, you have taken the subscription, and then I can show you the video, otherwise no. Okay, and then from here it will go to different services like video service, okay, which will do upload and manage video. Then second will be the search service, okay, search video, suggestions will come here. Then user service, so users profile, authentication, subscription, everything will maintain with this service. Recommendation service, so recommendation or personalization will be done from here. Okay, so these are the 4 responsibilities of the our application. Now flow will be something like this. See, user will upload a video. Okay, now we will store that in a object storage, let's say S3, okay, AWS, and then transcodes to multiple formats. That is what I told you, right? 240 pixel, 480 pixel, and something like that. And then it will delivered via CDN and played on user's device. So very simple. See, if I'm uploading video, okay, I can't store that video in a database. It's a very big huge space it will take, right? So what we do, we store this video in object storage, let's say S3, okay, from Amazon's AWS side. But the metadata of that video, what is the title, what is the description, okay, all metadata, who has uploaded it, okay, that one we will store in a database. So this is 2 things. One is object storage, and second is your database. Okay, now when user will, and then asynchronously it will create a copy of this video, okay, and then it will transcode it to different formats, and then we'll again store that format to S3. And then when user will request for the video, so from CDN, okay, via CDN content delivery network, it will get it will play it on the user's machine, okay, user's device. So metadata DB will get stored. Okay, we will store the metadata DB, and then object storage, so original video will get stored in a object storage, and then transcoding service will convert it to multiple resolutions. That is called resolutions. Okay, and then content delivery network will serve you that video, and then video playback, so user stream the video. So this is the thing. And then what are the benefits? Is scalable, high availability, fast video delivery, and better user experience. Okay, why fast video delivery? Because we are storing this in a S3 storage, and then via CDNs. Okay, CDN you will have a edge servers, and then whatever server is nearer to your location, it will get served from that location. Okay, so request will not go to origin server and directly not come from there, so the latency will be less here. Okay, so now user flow, let's talk what is that. So creator will upload the video and then store the original video in object storage like S3. Transcoding services generate multiple resolutions like 240 pixel, 480 pixel and all, and then store transcoded files again in S3. Okay, then update metadata in a database, and then CDN cache popular content. Okay, CDN will cache what is the popular nowadays everybody will watch that, so it will cache that content. Okay, let's say at night time he will do all these things. Now user streams from the nearest CDN, right? So this is the normal flow of a video streaming, like if you talk about Netflix or you talk about Amazon Prime or YouTube, so everybody works with this principle only. Okay, now senior software engineer, what he will answer, let's say 7 to 12 years of experience. Okay, he will answer that I would break the platform into independent microservices. We saw that, right? Each service owns its data and scale independently. Heavy asynchronous workloads like transcoding and notification should be event driven. Right now you you have to be make it event driven, asynchronous call only, right? Because transcoding and all these things will take a time, because it will convert it into a multiple resolutions. Okay, multiple files will get created. For mobile, different resolution, for TV different resolution, for laptop different resolution. Okay, so Now production architecture, if you see from senior software engineer point of view, okay, so user will send, so the request, so user has requested for the video, okay, it will go to global load balancer. From there it will go to API gateway. Now different services like video service, and then search service, okay, and then metadata service, user service, recommendation service, playback service. Okay, what playback service is doing here, we will see that. Okay, it will not play the video, it will check whether you have a access, you have a rights to play this video. Okay, it will check your subscription and everything, and then only it will allow you to see that video. Now this layer has added, okay, Kafka events for the asynchronous calls. So what Kafka, through this Kafka events, what you will do, okay, so like asynchronously you will run transcoder service, thumbnail service, okay, which will create a thumbnails, and then notification service, analytics service, all these things, and then after creation of those files, it will store that in object storage, and then cache in CDN. So next time user will request, it will come directly from CDN. Now key production decisions, if we talk about here, so it should be stateless service. Okay, we will see that is stateless service here. And then Kafka for asynchronous processing, this is what we discussed. Okay, Redis for caching, Elasticsearch or OpenSearch for search. Okay, I'm searching my movie, so there we will be using this. And then object storage for video, CDN for global delivery, auto scaling, health checks, circuit breaker, and retry policies. We will talk about all these things. So see, a stateless service is service that doesn't remember anything about previous request. Every request contains all the information needed to process it. Okay, so for example, shopping website. So where how stateless service we are using here, let's say you have a API endpoint get products /123, okay, and then in authorization you have a this bearer token. So now the request itself contains everything what is needed, right? Because we have added this token in this request. So user token and product ID, right? It doesn't have to depend on the another request or the or any other connection. Okay, so the server processes the request and return the response. It doesn't store anything in memory for the next request. Okay, so this is a stateless service. Now principal engineer or architect, what he will answer, so expected answer from him would be, at Amazon scale, Prime Video is globally distributed platform. Okay, globally, not only for India, it is globally distributed. Okay, all over the globe the people is serving this means using this application. The architecture must optimize latency, availability, resilience, and operational cost while supporting millions of concurrent viewers. So enterprise architecture would be something like this. So from Route 53, okay, Route 53, the traffic will come to global traffic manager, and from their regional API gateway. Okay, here we are not talking about API gateway, we are talking about regional API gateway. So architect is talking about global system. Okay, so there the global system will be divided into multiple regions. Okay, so that. Now video platform control plane you will have, and what will be there in this plane, your upload, playback, search, metadata, recommendation, DRM. Okay, what is DRM? Digital right management, analytics, and notification. Okay, from this you will have different services there, and then from this request will go to global event platform, and from there multi-region object storage. Okay, so now here you don't have one place where you're storing entire application data. Okay, you will have a regional S3s, let's say, and you will store files there. Let's say some content is popular to particular region only. Okay, then it will get served from that regional storage only. Okay, it will take less time. So now, so it will go to global CDN then, and then will go to customer. So here DRM is digital right management, is a mechanism that protects videos from unauthorized access, copying, and piracy. Okay, so here is the flow for simple interview friendly terms. See, Route 53 means DNS, okay, domain name server. So user enters the video platform URL, Route 53 directs the request to the nearest healthy region. Okay, now global traffic manager, so choose the best region based on the latency and availability. Now regional API gateway, so receive the request and forward it to appropriate backend service. video platform control plane. So here we have seen multiple boxes, like handles business logic such as upload, okay, which will upload the video, and then playback, check if user can play the video, and search is for the finding the video, metadata, video title, description, duration, okay, recommendation, suggestion of the video, and then suggest video, DRM, verify user access, and issue a playback license. Okay, it will issue a license, and then if you get the license, then only you can see the video. You will call that another API. Now analytics track views and user activity, notification, send alerts to user. Now what is global event platform is doing here? So publishes events like video uploaded or video watched, so other services can react asynchronously. Let's say video uploaded, okay, so then cache will start doing its work, okay, storing that video and all those things. Transcoding will do its own work, okay, will start its work. Now multi-region object storage, so store the actual video files across multiple regions for durability and availability. Okay, you're not storing that file in one region, you're making copy of that file in multiple regions. So if one region gets failed, you can serve a request from another region. Global CDN, so cache video close to user, so streaming is fast and reduce load on the storage. Okay, that is what we discussed earlier. Customers, the user watches the video from the nearest CDN with low latency, which is very important, right? Latency is very important for our system. Now playback doesn't actually stream the video, it prepares everything needed before streaming the starts. So that is what I told you, playback is not for the streaming the video, okay, it will just check whether you have access or not. So flow will be like user will click on play button, okay, the playback service check that is the user logged in, or does the user have permission to an active subscription, is the video available in the user's region. If everything is valid, it returns a signed playback URL, okay, manifest URL like HLS or DAS, and then a DRM license or token, okay, if DRM is enabled. So the video player then uses this URL to fetch the video from CDN. So now this video player, after that it will fetch the video from CDN, okay. So this is the normal flow for DRM. Now design principles. What design principles you will be using here? Active region. So you will deploy your application in multiple region, and from multiple region you're not using those multiple region deployment as a copy, okay, or replica. You will serve a request or response from that, you will serve response from those regions, okay. Those are active deployments. So that's why active region. Then you have an active passive region where you have just deployed it to another region, just in case if anything fails to this one, you can divert that request to another region. So that's why you use that, okay. So active region we will use here, design principle. After that, multi CDN strategy you will be using here, okay. Not only one CDN, multiple CDN we will be using. Now regional failover, if one region will get failed, so another you can switch. Then event driven architecture, okay, everything you are doing using the Kafka, and auto scaling, okay. After that, service isolation, sale based architecture, so entire globe will divide it into multiple sales, okay. And then zero downtime deployment, whenever you are deploying your application, user will not wait, okay, he will not see that your application is down, he will do deployment, like for example blue green deployment. So to another environment he will be doing deployment, one that is ready, you will just redirect request to that deployment, okay. Or canary deployment also you do, right? Now comprehensive observability, okay, lots of things he will include there which he will monitor. And then cost aware storage life cycles. So like for example, if the video is lots of people are watching that video, so I will be storing it in a cache, okay, hot storage. If not much people is watching that, so I will store it in a cold storage, okay, which will be the cheaper. Then after that, if there is a zero views, okay, or nobody is watching from last 1 or 2 years, so I will store that in a archival storage, okay. So that will be cheaper, okay. So that is how you will do the cost optimization here. Now comprehensive observability means having complete visibility into how your system is behaving, so you can quickly detect, troubleshoot and fix the problem. That is why comprehensive observability is needed here. Suppose users complain the video keep buffering, okay. With comprehensive observability you can see logs first, right? Did any error occur? Metrics. Is CPU usage high or CDN latency is increasing? Okay, then you will trace traces. Then which service is slow? API gateway, playback, DRM, CDN, etc. This helps you to identify the root cause quickly. Now let's talk about 16 follow-up questions here. Okay, so the first follow-up question is related to video upload pipeline. So software engineer will say about video upload pipeline is users upload video through the API gateway. The video is stored in object storage and an event triggers and the transcoding service. That's it. Okay, so video upload means what you need to do. You upload the video, okay, and then it will get stored in object storage S3, and then from there the video it will trigger one event, okay, asynchronous event for the transcoding service. So it will create a different resolutions and then again store in a object storage and then metadata in database. So this is the normal flow, okay, from software engineer perspective. Upload, so user upload the video, it will go to API gateway, from there object storage, Kafka, transcoder, and then metadata update. Okay, what senior software engineer will say here, I would use multi-part upload for large files. Okay, so now let's say one large video is there. Okay, it will first chunk it into multiple parts, and then those parts it will convert it to multiple resolutions. Okay, so that is what he will say, multi-part upload for large file. Checksum validation also. Okay, then resumable uploads. Okay, if user has resumed it, okay, any network issue happen, so next time when again he will connect to internet, the upload should resume from the last endpoint, not from starting. Okay, and then asynchronous processing through Kafka. What architect will say, the upload pipeline should support retries, virus scanning, deduplication, content validation, regional replication, and backpressure handling. So now follow-up question 2 would be related to video transcode. So software engineer will say that generate multiple video resolution, so user can stream based on their bandwidth. Okay, now senior software engineer will say for this is transcoding workers consumes job from Kafka and process them independently for horizontal scalability. Okay, so yeah, so senior software engineer will always talk about asynchronous processing, right? And then architect will say use GPU accelerated transcoding, because GPU is fast, right? Auto scaling worker pool, job prioritization, and support modern codec like H264, H265, and AV1. Now follow-up 3 would be related to CDN. Okay, so software engineer will say that the CDN cache videos close to the users, reducing latency and origin load. Senior software engineer would say that I would cache popular content aggressively and use signed URL for secure access. Okay, DRM he is talking about here. Architect will say that use a multi-CDN strategy with intelligent routing, edge caching, origin shielding, and continuous cache hit ratio monitoring. Okay, so now what is origin shielding here? Origin shielding is something like this. See, you will have a different CDNs, okay, CDN layers. So first you have a origin server, and then you have a CDN1, CDN2, and CDN3. Okay, so when user request to this CDN, okay, there would be one shield CDN also between origin CDN and edge CDN. So if request is not there in this edge CDN, it will go to shield CDN and then will take value from there. So it will shield your origin server, right? See, edge CDN1 misses the cache, ask for the shield CDN. If the shield CDN has the video, it returns it immediately. If not, only the shield CDN fetches it from origin, okay, and nobody else. Now follow-up 4 would be DRM, okay, digital rights management. So software engineer will say about DRM is that encrypt video and content and issue playback licenses only to authorized user, okay, which is correct. Now what senior software engineer will say that separate key management from content delivery and issue short-lived licenses after authentication. Okay, now what is key management here? So support Yeah, so key management means you're storing that in a CDN, right? In a cache. So that key management, separate key management from content delivery and issue short-lived licenses after authentication. Now, architect will say that support multiple DRM standards like white wine, fair play, or play ready, okay? And then secure key rotation, hardware backed playback where available, and audit accesses, okay? Now follow 5 would be related to recommendation engine. So for recommendation engine, software engineer will say that recommend videos based on watch history, okay, and viewing preferences. Senior software engineer will say that generate candidate recommendation using ML model and ranking algorithm, then cache a personalized result, okay. Architect will say that combine collaborative filtering, content based recommendation, trending signals, and contextual features. Keep recommendation logic separate from the playback services. Now what all these terms, okay? So first we have talked about collaborative filtering. So what is collaborative filtering? Recommend videos like by user with the similar interest, okay? So for example, people who watch Stranger Things also watch Dark, so that is the collaborative filtering, okay? Now content based recommendation means recommend videos similar to what you just watched, what user just watched, similar to that, okay? So if you watch action movie, recommend more action movies. What is trending signals? Trending signals means recommend videos that are popular right now, okay? For example, top 10 trending today's. And then contextual feature means recommend based on the current context. Example, show kids cartoon on a child's profile, or recommend comedy in the evening. So this is the contextual feature. Why keep it separate from playback service, okay? Because see, playback services only check the permission and start streaming the video, okay? That is the work of playback service, but recommendation service decides which video to recommend, okay? So both have the separate services. Keeping them separate makes the system easier to scale, maintain, and update without affecting video playback. Now follow-up question 6th is resume playback, okay? You can resume also the video. Store the last watch timestamp for each user and video. For example, user 123 was watching movie 456, okay, and then he switched to from that playback screen. So position would be 42 minute 15 second he left, okay? So whenever next time he will start that video in his let's say he was watching on laptop, and then second time he will start on his mobile, so it should start from that timestamp only, okay, in each device. So it should support all the devices. So software engineer will say about this related to store last watch timestamp, okay? Senior software engineer will say that persist playback progress asynchronously and update it periodically instead of after every second to reduce the write load. So he is saying asynchronously you need to persist that value, right? Like after 5 seconds he will store that timestamp, after 5 seconds then he will store the another timestamp, okay? Not every second. Architect will say that replicate playback progress across regions so user can seamlessly continue watching on any device. This is what I just explained to you, right? Now follow-up 7 would be related to live streaming, okay? So live streaming will be use chunked videos streaming, so viewer receive small video segments continuously, okay? So not entire video will come at once. Live streaming, chunking of the videos will come, okay? Senior software engineer will say support adaptive bitrate streaming, age distribution, and low latency protocol, okay? ADR we have seen. Now ABS, sorry. So now architect will say that separate the live streaming pipeline from video on demand, optimize for low latency, auto scale ingest, and distribute independently. Follow-up 8 would be related to watch history. So software engineer will say store watched videos with timestamp for each user. Now here senior software engineer would be expected to answer publish watch events, okay, through Kafka. So recommendation, analytics, and personalization service can consume them independently. So different services will consume that using the Kafka topic. Now architect will say that treat watch history as an event stream with long-term retention and privacy controls. Follow-up 9 is related to multi-region, okay? So in multiple region you will deploy your application. Deploy service in multiple region to improve availability. Senior software engineer will say that use active deployment with regional databases where appropriate and fail over traffic when a region become unavailable. Okay, so active deployment we have talked about. Now architect will say that adopt seal based architecture. Okay, so entire globe will divide into multiple seals. Regional isolation, automated failover, and asynchronous replication while balancing consistency and latency. So copy asynchronously, create a replica of those data also, okay, in multiple regions. Now follow-up 8 is related to caching. So software engineer will say that cache frequently access to metadata and user session in Redis. And now here senior software engineer will say that cache metadata, okay, recommendations and search result while defining appropriate invalidation policies also. So here he's talking about invalidation policies. Architect will say that implement multi-level caching, okay, not only single caching, multi-level caching like application cache, Redis, CDN edge cache, and monitor heat ratios to optimize latency and infrastructure cost. Okay, follow-up 11 would be related to search. So software engineer will say that index movie title, actor, genre, and description in search engine. Okay, senior software engineer will say that support autocomplete, fuzzy matching, and fuzzy matching means we'll see here. Okay, let's say user has typed Netflix instead of Netflix, so he will know that okay, he's talking about Netflix only. So that is the fuzzy matching. Okay, and language specific analyzer. So interviewer, you can think fuzzy matching is approximate matching. Okay, matching similar but not exact text. Architect will say that use a distributed search platform with ranking, personalization, typo tolerance, and continuous index updates. Okay, so he is talking here about continuous index update, typo tolerance, okay, personalization, and platform with ranking, and distributed search also. Okay, now follow-up 12 is related to storage. Software engineer will say about a storage is that store video files in object storage S3, right, and metadata in relational or NoSQL databases. This is what I told you earlier. Senior software engineer will say that separate hot, cold storage, apply lifecycle policies, and replicate critical content. Okay, hot storage, cold storage, and then archival. So these things, okay, related to storage, you can say that lifecycle policies also. And then you will replicate the critical content. Okay, not all content, but critical content at least replicate. So for example, okay, suppose a creator upload a video. So first 30 days, okay, store in a hot storage because it's watched frequently. And let me tell you, hot storage is expensive, cold storage is less expensive than hot storage. Okay, now after 30 days with low views, if views are not coming, then why to store that in a hot storage? Okay, you can store something else in there. So automatically move to cold storage, which is cheaper. After 2 years with no views, okay, archive it or delete it depending on the business requirements. So real world example will be day 0, upload video to hot storage, okay, fast access. So why, what are the meaning why they are expensive? Because you can access video faster there. Okay, day 30 move to cold storage, which is cheaper. Okay, so it will take some time to fetch video from there. And day 730, after 2 years, archive it or delete it. Okay, so architect, what he will say about storage is optimize the storage using compression. So here he is talking about the compression. Okay, then tired storage, different tired. Okay, hot, cold, archival, lifecycle management, and deduplication when where appropriate. Okay, let's say one video you have uploaded 5 times, why to keep 5 videos? Okay, just keep one video, no? Then cost aware retention policies. Follow-up 13 is related to metadata service. Okay, so software engineer will store movie title, description, cast, language subtitle in and video locations in database. Senior software engineer will say about this metadata services. So these are metadatas, okay, title, description, cast, and then language subtitles, video locations. These are metadata. Now senior software engineer will say that keep metadata in a separate metadata service with APIs. Other services like playback, search, recommendation, fetch movie details from the service instead of storing their own copies. Architect will say track metadata changes like versioning. Okay, first the video description was different, now it is different, so you need to keep these changes also. You need to store these changes also, so using versioning you can store that. Support multiple languages, okay, localization, and ensure old client continue to watch even after metadata changes. Backward compatibility. Okay, it should support backward compatibility. Now, for example, versioning. Okay, movie description is updated without losing the old version. Localization, the title Avenger in English and Avengers in Hindi. Okay, you are writing it differently. Backward compatibility, if the new field like age rating is added, older mobile app still work without breaking. Okay, now follow 14 is related to notification system. So software engineer will say notify user after new release, subscriptions and downloads. Senior software engineer will say about notification system, what you need to notify. See, publish events to Kafka and let notification workers send email, push or SMS independently. Now architect will say use an event-driven notification platform with user preferences, rate limiting, retries, date later queue, and campaign scheduling. Okay, so he's talking here about dead letter queue, retries, rate limiting, okay, user preferences. Okay, so he's talking about all these things. Why? See, respect user notification preferences, limit notification frequency, rate limiting, that user has said I need to see 2 notification only from Amazon Prime, okay, every day, so not more than that. So those things, okay, limit notification, and then retry failed notification and move permanently failed one to dead letter queue. So all these things you will manage. Okay, support schedule campaign. Schedule campaign means send promotional notification at 9 a.m. to all user while ensuring the platform scale reliably. Okay, follow 15 is related to cost optimization. So software engineer will cache popular content and remove unused temporary file. Senior software engineer will say that use auto-scaling lifecycle storage policies, efficient codecs, and optimize CDN cache hit ratio. Okay, this is what we just talked about. Now, architect will say that optimize across storage tiers. Okay, transcoding resources, CDN usage, compute auto-scaling and data transfer cost while continuously monitoring cost per streaming hours. So he will talk more on detail, okay, on different things. So now follow up 16, this is the last 16, 17, okay, we have a 17 follow-ups, okay. So 16 is related to disaster recovery, okay. So software engineer will say about disaster recovery is maintain backups and deploy services to multiple regions. This is very simple, right? Software engineer will say, senior software engineer will say replicate metadata and critical services, okay, and then define recovery time object. So here we will talk about 2 things, recovery time object RTO and recovery point object RPO. Okay, so and regularly test failovers. So now what is RTO? So how quickly the system must be restored after failure, that is recovery time objective. Now recovery point objective is how much data loss is accepted after the failure. See, failure happens, so some data will get lost, right? So that will define in RPO. Architect will say use active regional deployment, automate failover. Okay, automate failover means anything failure happens, automatically request will transfer to different region. Regularly perform disaster recovery drills, ensure no single point of failure across the platform. Follow up 17 is related to observability. Okay, so software engineer will say that he will monitor API latency, error rate, video buffering, and upload failures. Okay, now senior software engineer will say he will also monitor, apart from these, he will also monitor CDN cache hit ratio, transcoding queue length, okay, Kafka consumer lag, search latency, and playback startup time. Principal software engineer or architect will say for this is that for observability is for a platform like Prime Video, I would define SLO, okay, monitor business systems and customer metrics. So service layer objective, okay. So playback success rate, now startup time to first frame, okay, how much time it is taking, and then rebuffering ratio, P50, P95, P99, API latency means 50% latency in how much time you will be delivering, okay, then 95% of the response in how much time you will be delivering, and then 99%, okay. CDN cache hit ratio, okay, how efficiently you have cached your data, so that CDN cache hit ratio will be there, okay, not the miss ratio. Transcoding throughout and throughput and failures, storage utilization and lifecycle cost, okay, Kafka consumer lag, if there is a consumer lag anything, okay, and then regional health and failover events, recommendation click-through rate, means you have shown, you just gave the recommendation to user and how many user have clicked on that. Okay, and then you have to determine the conversion rate also. After that, cost per streamed hour, and then service availability 99.99%. I would build centralized dashboard, okay, distributed tracing, structured logging, and automated alerts, so issues are detected and resolved before they significantly impact customers. So he's talking about here centralized dashboard. Okay, one dashboard from where you will see all the this matrix. Then distributed tracing, okay, multiple services where the actual problem is occurring, and then structured logging, and then automated alerts. So that's it. Thank you.